Hi everyone, I'm Anantaram Varatharajan, a recent Ph.D. graduate of the Power Electronics and Innovation Center in Polytechnico di Torino. The topic of my research was on the generalized sensorless and advanced control of synchronous reluctance machines, supervised by Professor Gian Mario Pellegrino. A quick background. I did my bachelor's in electrical and electronics engineering from Witzbrown University in India. Following that, I was a research intern at the TU Dresden for a year, working on power quality and harmonic emission of electric vehicles. I did my master's in sustainable transportation and electrical power systems, which is an Erasmus Mundus master course organized by a consortium of universities that are shown here. Since 2017, I was a PhD student here in Politecnico di Torino. The date of my defense was 12 February 2021, and I'm honored to have had a very distinguished panel in my defense commission, which included Professor Sulp from South Korea, Professor Fernando Brits from Spain, Professor Inkinen from Finland, and Professor Petrella from Udine. The scope of my work broadly touches on three aspects. The first and the primary one is on the sensorless control of synchronous machines, which is operation without a position transducer. The main motivation, the cost reduction and reliability. The second topic is the self-commissioning, which is the identification of the flux to current relationships that is also highly nonlinear in synchronous machines. Besides identification without a dedicated test bench or any additional hardware finds practical importance. The third is on the optimal control design, that is operations at the extremums of the drive for high performance applications. In the following, I shall discuss three selected findings in the sensorless control. Stated resistance is temperature dependent and is prone to variations, which in many cases adversely affects the position estimation. So a new sensorless technique called APP, which is an abbreviation for adaptive projection vector for position error estimation, was designed to be independent of resistance and thereby immune to its variations. This is an experimental validation where the resistance term is perturbed by plus minus 100%, and the corresponding effects on the flux and torque are observed, and yet the position error remains uninfluenced, illustrating the resistance immunity property of the APP technique. The second finding is accurate torque control, which is an important feature for industrial and automotive applications. This accuracy is compromised when the flux maps is imprecise. So in addition to the position estimation, a second and independent parameter adaptation loop is designed such that the torque estimation is accurate. This is the experimental validation where the error in d-axis is increased from 0 to 50%, and in the first test without the adaptation, the torque reduction is observed, whereas when it is enabled, accurate torque is realized despite the error in position. A third finding is on a plug-and-play sensorless control requiring no flux map information of the machine under test. This is challenging, particularly at 0 to low speeds region. To this end, a new technique called LIST is developed in collaboration with our industrial partner Mitsubishi Electric. This has been validated on different machines, and the novelty has been patented. This is a snapshot of the setup that shows the HPM data recorders, D-Space platform, the custom inverter, and the motors under test. On other activities, I'm an advisor for master thesis students, and I've been contributor to 3 industrial projects. I'm also an active reviewer in all major IEEE journals and conferences. My publications include 9 transaction papers, 7 conferences. I'm a recipient of Best Paper Award and have co-authored 4 patents. In the future, I wish to explore multi-phase machines and also grid-connected converters. I conclude with gratitude to my co-authors. Thanks for listening.